So anybody else, any questions, any reflections on the session? No?
Oops.
All right. So let me move on. Just give me a second.
Hello, everybody.
Hey, Rainer, how are you?
Hi.
Thanks.
Hello, Rainer.
I'm just sharing my screen. Just give me a second. We're going to run this PEI trailer again for the
Polar
benefit of those
Educators
who have just
International
joined.
is connecting educators, polar researchers and communities for a better understanding of polar knowledge. Earth's polar regions are remote, beautiful and challenging places, and they have a profound influence on every one of us. We know these vast amounts of snow, forming ice sheets, sea ice and glaciers, together with massive currents of cold water, contribute dramatically to the climate and ecosystems of our world, systems which in turn drive the health of our local environments and communities. Research shows dramatic change in the Antarctic, in our mountainous regions, and particularly in the Arctic, home to over 4 million people, which is changing faster than anywhere else on Earth. Scientists are confirming that human activity is playing a significant role in these systems, increasing the planet's surface temperature in ways that cannot be balanced out by natural processes. It is clear the urgency to engage the next generation in polar research and to rise to the challenges that a changing climate will bring has never been greater. United in our passion for sharing the importance and value of the polar regions, educators and researchers from around the world have formed PEI, an essential global network developing polar knowledge to engage a global audience facing climate change. We are collaborating to strengthen this community, building resources and relationships, and helping local audiences connect polar research to their everyday lives. Polar Educators International amplifies the voices of all those dedicated to understanding and protecting our extraordinary polar regions, and all Earth's inhabitants, for generations to come. Join us.
I think everyone's eagerly waiting for Iceland to just come by. But yeah, I think one of the initiatives that we had was obviously organize the Equinox Share-a-thon as a precursor to the Iceland conference. Hladboard in Icelandic, which basically means buffet or a loaded table. I'm not sure how much food is there, but I think it's going to be a lot of events which would be happening along the way. And I think one of the important aspects about PEI was also have it in somewhere that is officially polar. And I think nothing better than Iceland in terms of the diversity to, and scope for actually conducting this conference. So as a build-up, we've been having some events, which has been in the form of tech tasters. We're having the Share-a-thon. And for this particular session, we have with us a few people from Germany. So let me quickly run you through the names, and I'll be handing it over to Rainer after that. So Rainer, I met in Cambridge last, and I don't get to see him much, but I get to see his newsletters. They're like Aladdin and the Magic Lamp, and you rub and there's a newsletter every week. So that's how I get to know what Rainer is up to. And I think in terms of people have been fairly passionate about polar education and epitomize the value of PEI. I think Rainer is one of them. We have a few more people. We have Monika joining us. Welcome, Monika, if you've already joined us. Marek, I did see you log in. Welcome again. Josephine has been there actively participating in Taboo. Welcome again. And Friederike, welcome to the Sherathon of PEI. And without much ado, I just want to hand over the podium to Rainer. And Rainer, it's all yours. I'll be making you a co-host. So if you want to share anything, you'll be able to do that.
Yeah, thank you very much, Rem, for your kind introduction. And I now will share my screen.
Just give me 1 second. I'll just. I made you the co-host, so you should be able to share your screen now.
Okay. So let's have a look. Must be in this one here.
Yep, perfect.
So, okay. Yes, Polar Educators Germany started as a project called Cool Classes in 2007, 2008 during IPY. But in 2008, we got involved in the German Society for Polar Research as a working group. And since then, we are working in the society. We are a group now for about, let's say, 300 educators from all kinds of schools all over Germany, all ages of students, and all topics, I would say. Our main targets are bringing polar research into the classroom. That's because there is a big lack on polar knowledge in German schools and education in the curricula, and to inspire young people for polar research. We want to communicate basics and interrelationships in the polar regions because of this lack in German schools. We want to do this by involving educators as multipliers and stimulating and involving students in polar projects. And we have also, of course, a strong cooperation with polar scientists and, of course, with APECS, the young polar scientists. So networking is for us a very important tool. This has different regions where we work. Let's say we have the Polar Educators Germany, and there we have collaborations between educators and between different schools. And of course, we have international cooperations, for example, with Polar Educators International, but also with other institutions. On the other side, we have the scientists from all specializations and from a lot of different research institutions. And we both meet in the German Society for Polar Research, and we will exchange their ideas and new programs and stuff like that. And so this is a very good instrument in Germany. The German Society for Polar Research, because we also get some funding from them for meetings or other things. Here are some examples from our 14 years of work. For example, we had a couple of expeditions with the participation of educators working in Arctic and in the Antarctic. And we have a lot of students projects. Here you see, for example, a building of or a model of the German Neumayer 3 stations, Antarctic station. Or here you see some students visiting Polarstern, or we have polar days and other projects. So students' involvement is very good. For educators, we offer workshops and advanced training, doing some experiments also, and we present our results on conferences and, for example, in talks and with posters, and we have presentations there. And also it's very important to have some publications, and you see some examples from our publications. So far in brief, if there is any question, I hope we have some time for questions at the end. And now we see also something from current projects from Friederike and Monika, and I will hand over to them. Thank you very much.
Do you want me to start, or is Monika starting?
Friederike, you start, I think.
Okay. I think I have to be a co-host then.
Yeah, I'm just making you one.
Okay, thank you.
Yep.
Mm-hmm. Mm-hmm.
I think Rainer might need to stop. Yeah, it's working now.
Okay, yeah, I think now it's working.
Mm-hmm.
Okay, thank you, Rainer, for this introduction about the polar educators in Germany. I think right now I'm one of the two youngest polar teachers, as Falk, Ebert, and me participated in the MOSAiC expedition already 2 years ago, when we were able to accompany the MOSAiC expedition in the Polarstern with another Russian icebreaker for 6 weeks. So we spent 6 weeks in the Arctic on the way through, and of course also there. And we had the chance to see the Arctic scientists and the scientists' work in situ, and we tried to do a lot of school material about this. I had my camera with me to take pictures and make a movie out of this, and it was a very great adventure. So I think right now maybe I can tell you something about getting to expedition like this as a teacher, and maybe also the reason to take teachers with you to an expedition, and also the outreach that we are able to do also and still now. So it's over with the 6 weeks. We are still working with it. And Rainer, you've been in the Antarctic, in Antarctica. Sorry, I think it's already 12 years ago, or how long is it?
Oh,
I think it's
now 14 years ago, 2007.
40, yeah, and you're still very into it. So you see, to take a teacher with you can be a very, very productive way to transport the knowledge and the scientists' work. Yeah, how did I get there? Of course, I applied to get to this expedition, but the first thing is that the German Association for Polar Scientists, the Deutsche Gesellschaft für Polarforschung, and of course Rainer with the Polar Educators Germany decided and worked hard to get 2 German teachers on board of the Polarstern, or at least another icebreaker, and into the MOSAiC expedition. So they did a lot of work. They convinced Marcus Rex, and in the end it was possible to get not only the US on board. The US educators, but also the German ones. I applied and I was very lucky. I think it was something about my motivation, because the moment I applied, I haven't had a school yet. I was very young. I just had my first, I did my first exams at university, and I were in the middle of my referendariat. This is a kind of education for getting a teacher. I was very young, didn't have so many experiences, but I wrote my exam, my last thesis, something like a master thesis, about the shrinking ice, the glaciers, the shrinking ice of the worldwide glaciers. So I had some special interest in the topics. I've been to Iceland a few times before, so I had a high motivation to get into the Arctic. I was ready for this experience, and I think the whole combination, I have a past in the journalism, made me possibly fit for this job. So I got out of the school into the Arctic. And I think this was a really, really good decision, because I wrote this down just to visualize it. A teacher can reach about, and only if you're a lazy one, about 120 kids in 1 year. Yeah. So imagine you have around 4, maybe 5 or even more classes with about 25 or 30 kids roundabout. You will reach at least 120 kids with a topic of your interest, of your motivation, or whatever. And after 20 years, if you count it pessimistically, you will reach at least 2,400 kids. I think you will reach even more if you're very motivated, in contact also their families and friends. And that's what I am doing. If you're doing additional lectures everywhere, for example, in other institutions, in the university, in museums, and who else is interested in this topic? And there are a lot of people that are very interested in this topic. Of course, I can work for the media as a teacher as well. This was really interesting, and a lot of media colleagues contacted me for some interviews. So over the next 40 years, I will reach at least thousands of kids and grown-ups as well. And this is much more than if you take a journalist on board or wherever, and they will write a few articles about this and will go on with their other jobs afterwards. So the highly motivation and the didactic knowledge of teachers makes it possible that the topics that the very complex scientist work can be reduced in a didactic and very easily way to make it understandable for the normal people, for the kids, and for their parents and grown-ups as well. So we have the knowledge how to reduce it in a case where it must still be the right way, but we can reduce it and make it more easy to understand for everybody. And we ask questions, for example, and this is what the public is interested in: how does the climate change affect the Arctic in the end? They want to see numbers, but they don't want to see all the numbers in Excel sheets. They want to have it in a reduced way. They want to know what the MOSAiC expedition, in fact, is about. They want to discuss who owns the Arctic, who's responsible for what is going on there. Is it us? Is it me? Or is it someone else, like, for example, Denmark or Norway? And who's responsible for conflicts that could be possibly pop up now because of the resources that are expected to be under the ice? So they are asking what the scientists actually are doing there in the Arctic for the whole year. When they are not working, what are they doing in their free time? How do they spend the time on the ship? How does it feel to be a woman on board? Or how is the darkness? How does that feel? What is life like on board? Or very specific questions that could be: how do they measure the ice thickness? How do they do this? With what kind of instruments do they do this? Or, for example, how do they read coordinates? And how important is it to know how to read it? All these questions we tried to answer on board or afterwards in the weeks when we got back to Germany. So we still stayed in contact with all the scientists that were on board or still were there or already returned. We tried to work as hard and as much as possible already on board. And out of all these questions, we made a lot of school material that you can find on MOSAiC expedition.org/education, or building for the German versions. We have it in English and in German, and the US Educator did a very great job as well with different materials as well. Yeah. And I want to show you briefly 2 or 3, I think 3 different examples of the material here. You can see, for example, different instruments that are used, and you will see this little sheet on the right side where a lot of different instruments are described. How, for example, their weight, their cost, maybe also how they are installed, and what kind of parameters they can collect in the end. And out of this material, you can play different games. You can try to be a scientist and decide what kind of instruments do you want to install on your flow or whatever. A second thing that I want to show you briefly is the sheet about the coordinates and how to use it. You would see the coordinates of the Russian icebreaker on different dates before the meeting with the Polarstern that you can see on the right side above. So you have the coordinates that you can sign in the little map that someone made for me. And on the right side, you would see an additional task for the fast kids about the meeting of the 2 ships, where you could do something like, it's in German, we call it Schiffe versenken, where you would sign in both ships and try to see how close they are together. Yeah, and the second one that is really interesting and used a lot is about the discussion of the owner rights of or in the Arctic. I only show you the pictures. It's a very complex worksheet, but I think this is one of the most important and modern questions we have to ask right now, because Russia is right now the head of the Arctic Council, but instead of deciding very difficult questions about the climate change or the prevention of climate change, they are building more military stations there. They put up a flag on the ground of the Arctic Ocean, and there are a lot of discussions about the Northeast Passage to handle the freight routes. So there's a lot of going on in the Arctic besides the climate change effects. And I think this is one of the most important and interesting questions teachers should try to discuss in school. Yeah, these are the 3 things I wanted to show you briefly, but if you're really interested, and you can contact me, or you can find it on mosaic.org. Yeah, and I think the last sheets here were just to show you that I did a lot of things just to impress you, but actually it doesn't matter. I just held a lot of lectures. I still do. I did it yesterday, and it's a lot of fun for me to inspire others to bring it into their schools, into their families or whatever. But well, it's not that it's not a happy topic anymore right now, as we have the elections here and we know that the Green Party won't get it. I'm getting more and more depressive, because all the things that I am talking about are very sad, and I don't see a chance for the Arctic as we saw it here 2 years ago. But this is too much for now. Just some pictures, and one thing that I want to show you, or that I would like to recommend you, is my short movie, not the one you can see here, but you can find it on YouTube if you Google mini documentary about MOSAiC. It's about 12 minutes long, and you'll find it in German and English. I worked like 1 year for this and you could use it in every school, in every lecture, whatever you like, because it describes not only the effect of the climate change in the Arctic, but also the whole MOSAiC expedition, their goals, and what is going on after the expedition. I think that was it. Yeah, well, that's totally enough. Okay, I think I'm done. I'm not sure how long it took. I'm sorry if it was too long. Okay. I saw some questions popping up. Is there something I would? No, I don't think so. Okay.
Not yet. No.
Okay. Yeah.
So in terms of, I just had one question on the resources that you developed. So do you consciously develop resources in German and in English, or how does that work when as an educator in Germany?
No, not at all. But we try to produce some of the material the US educators on board. So we have some parallel materials that are kind of identical. But all the things I've done afterwards, after the expedition, is only in German. So, but you will find other different materials from the US educators that is really good on the MOSAiC expedition website as well, if you would use it, if you need it in English.
Got it. Perfect. Thank you so much.
Who's going next?
Monika.
There are the slides actually, Ram. The slides for
I did run through all the slides initially so that Rainer could go through each one himself. So
all right,
yeah.
Okay. So who is next?
Monika, right?
Monika.
Monika, okay. Going
Hello,
next.
Monika.
I'll just make you the co-host.
I'm here.
Sure.
I've just made you the co-host, so in case you want to share your screen or just talk, I think you can go ahead.
Yes, I took the button Bildschirm freigeben. So it doesn't work. Huh?
Monika, you have to choose. There pops up some pictures, and you have to choose the right one.
Jetzt haben wir es, ja?
Yeah.
Okay. So hello everybody. I have a similar expedition experience like Friederike has. It is about 10 years ago, and it was with Polarstern to the Neumayer station. And actually, I'm working for a museum. You see the museum here, and we had an extra exhibition about this experience. You see, we call it tomato. I think it's the English word in the Scott tent. And this guy is very important for us. This is Georg von Neumayer. You know the name from the German station, and we have a strong connection to Neumayer with the museum. Our museum is called the Pfalz-Museum für Naturkunde. It's in Bad Dürkheim. And after this expedition, I had a lot of activities similar to Friederike, and I had some more time, so 10 years now, and I have a lot of experiments too. And for today, I decided to present you one concrete example, how to bring polar research into classrooms. So this might be the situation in the classroom. We have an output from the researchers, one graphic, that shows the changing pH in the surface water. So it's not the temperature, it's the pH from 1990 with a prognose, with a prediction until 2090, so 100 years. And the most affected region is the Arctic. So you see the most dark color in this region, and the decrease is 0.5 minus of the pH. So it's getting more acid. When you show this graphic, students have questions.
I think we lost audio for a little while.
Bitte? Bitte? No. So students ask questions like how sour is the ocean, or how sour can the ocean become, and why is the Arctic the most affected region, and how do animals deal with this change, and is it good for the atmosphere, or what is the connection to climate? Then we have a curriculum for chemistry in Rhineland-Palatinate, where I'm a teacher, and we have there a chapter that's called Acids and pH. And we have a chapter that's called, I tried to translate it, a focus on substances with relevance for the environment and the climate. So you see there is a very good match to the curriculum in our land. So the hypothesis might be the carbon dioxide dissolves in water, and this might be the reason for the decreasing pH and the acids. So I want to practice the students, so they get some work to do. So there might be the question, does carbon dioxide dissolve in water? And they have to show this in an experiment. They have different ways to find this out. And the way I show you here is that they have an injection of carbon dioxide from this injection, from this gas that goes in this measuring glass, and it measures the volume of the gas. So they know the amount of gas here and here, and so they can compare it. But you have to be careful, because it might be some more gas that should be dissolved, because you pass it once here, and if you do it a second time, then there might be some more gas. So the first result is carbon dioxide dissolves in the water. So you see, it's not really new for us, but it might be new for students to show it in an experiment. So they have heard of it, but it's a different thing to do it practically. So the next question might be, how much is it? So find out, quantify the solubility of carbon dioxide in water. That is not very easy because of this second round you have to do. Here you have one possibility how to find this out. You have some gas here, you bring it in water. In the best case, you have something like this to make very, very small bubbles. And so you have a large surface to solve the carbon dioxide. Then you change the glass here, and then you bring the gas back, and you do it several times until you have no more change. Then you get a volume as a result, a volume that you can bring into special amount of water. And then you have to calculate, because normally you have to give a measurement in gram, so a mass. So you have to calculate from the volume to the mass. And this will be the result. You have a difference when you have warm water or cold water. And you see the carbon dioxide is much better dissolvable in cold water. Now, what is the impact of carbon dioxide on the pH? This is easy for students when they know the indicators. So they pipe the carbon dioxide through water, which is colored from an indicator, and observe a change from green to yellow, which means that the pH is diminishing. It is more difficult to appoint the acid, so it's carbonic acid, and to give a reaction equation. Deepening, they heat the water and observe the red change of color. To describe what is going on, it is important to distinguish between the carbon dioxide as a gas, the carbon dioxide dissolved in water, and the acid. Those are three different substances in the chemistry view. Thinking about this gives an idea of reversibility of chemical reactions and a perspective on what is called equilibrium in chemistry. So just one slide, excuse me. Maybe if you are not a chemist, you don't like it too much, but you see for students which are 14, 15 years old, this is possible to work on. So you have the carbon dioxide as a gas, you have it dissolved in water, and you have the reaction with water to the carbon acid, and then you have some other equilibriums which you shouldn't name as equilibrium in this age of students, but maybe you can describe it as a reversibility. So this means for the ocean, the carbon dioxide of the atmosphere partly becomes dissolved in the ocean, and the dissolved carbon dioxide in the ocean partly moves back to the atmosphere. Then carbonic acid is built and dissociates. So the hydrogen ion, this one, is responsible for the pH. For the elder students, if you don't want to describe the chemical reactions with formulas, you can use something like this. So you see the equilibrium with the different substances, and they are depending on the pH. So the expected change on the pH means that there will be less carbonate ions. So you see the expected change of the pH here. from a little bit more than 8 to a little bit less than 7. And you see here the carbonate ion, and you have less carbonate ion when you have more acid. Unfortunately, those carbonate ions are used by many animals like corals and mussels to build their shell. So that's the problem from the biological view. Now, next step, the pH scale. So during the last 200 years, the pH diminished from 8.2 to 8.1. So we are in this region. This is astonishing because the ocean isn't an acid. It has a pH of 8.1 actually. And the expected diminishing is to 7.7 or 7.8. So it seems to be a small step, but because of the logarithmic dependence, that means the 0.1 means 30% more hydrogen ions. And this is more impressive than the 0.1. Yeah, that's what you can think about this experiment. Let's go back to some experiments. Let's find out where is the acid built. So we have a model ocean in a glass bowl, and we have some candles swimming in water with an indicator. And when we burn the candles, when we put a second glass bowl on top of the first, so that the carbon dioxide stays where it is. And we will have a reaction between the lot of carbon dioxide in this model atmosphere and the water. So we get on the surface of the water the yellow color that shows us that there is an acid. So we have the acid at the surface of our ocean. Now find out, does the acid stay at the surface? There we have a very nice experiment. We have a kind of aquarium, so a glass rechteckig. And you put water in this aquarium with indicator again, and you have on the bottom cold water, so tap water, and on the surface warm water. You put a plastic between, which you put out when you have the two layers in the bowl. So the one is warmer than the other one, so you have two layers. Okay. Then you pipe carbon dioxide in the upper layer. With a aquarium, it's a kind of a stone which produces very small bubbles when you have a gas bottle beside. So you see where you have the carbon dioxide, you have it only in the upper layer. Then carefully you bring a big ice cube in the upper layer into the ocean. And you can discuss with the students what they expect, what will happen now. And you see this, you see a movement because of the cold water from the ice cube sinks down, and it transports all the water from the upper layer down to the bottom, and from the bottom, like in the ocean, from Antarctica to the equator. And you see how die Strömung.
Current. Monika, the current.
Current, genau.
Wo wir gerade beim Sprechen sind, Monika, wir haben nicht mehr so viel Zeit. Du müsstest jetzt vielleicht so langsam zum Ende kommen.
Ja, ich bin auch gleich fertig. We call this the physical carbon pump. Okay, and that's the end is like the beginning, and we think about what students learned when they do all these experiments. And what are the next steps? So we can discuss the impact of global warming on the equilibrium, the impact of using less fuel energy, the developing of new technology, or the possibilities of climate engineering. So the students have much more possibilities to discuss and to understand decisions, even political decisions to deal with the climate change. Yeah, here's all these experiments are veröffentlicht, published in a journal for teachers. This one, and you see here the experiments I showed you, and there are some more. So we have a long list of publications during the last 10 years from the Polar Teachers Germany. So thank you for your attention.
Thank you, Monika.
Thank you, Monika.
You're welcome.
It was interesting. Should we take questions now or towards the end, Rainer?
I think we answer questions at the end and switch now to Marek and Josephine.
Sure. Over to you guys. Let me just make Marek a co-host.
Should I start and you continue, Josephine? Okay, great. I see yes. Okay, I will just shortly kind of like give an overview about APECS Germany. And APECS is embedded, like APECS Germany is embedded in the APECS International. So APECS stands for the Association of Polar Early Career Scientists. And so this means we are like, this is a kind of like the bigger umbrella organization, but this is, the APECS International has a lot of national committees, and we see also here on the map in Europe that we have a lot of national committees in Europe. We have a lot like Northern America and a lot more around the world. And we have also a national committee in Germany where I'm part of the co-chairs. And basically the polar regions are defined as polar and alpine regions and the wider cryosphere. And the overall task of APECS International and APECS Germany is kind of like provide opportunities for career development, meet and share ideas and experience, and develop new research directions and collaborations, and promote education and outreach as an integral component of polar research. And this is kind of like where I focus the presentation or the short overview part about what does APECS Germany do for like education and outreach. But maybe first kind of like introduce you a bit to APECS Germany. So we have this, we organize ourselves as an active board with 16 members currently. And Josephine was also formerly a member and in the leadership team. So that's also great to also see people later on in all the outreach projects, and we work still together, and she's now part of APECS International. But we are like 16 members from different universities in Germany, and also partly not in Germany anymore, but somehow affiliated with Germany. And we have a rather strong network of about 350 undergraduate and graduate students, postdoctoral researchers, early career faculty members, and all of that. And in APECS Germany, there are people from like master student level to postdoc. So it's really a good point to connect with each other and to learn or get to know people in different career stages. So our main goals are kind of like this networking part. Therefore, we organize often like get-togethers, career development, for which we do workshops and so on, science communication and outreach, and then just like inspire young people about the polar regions, or like people of all ages. And one thing I wanted to highlight is from 2020. So last year we did a Cold Regions Cool Facts contest where we encouraged students at German universities to contribute some kind of creative format showcasting polar research or polar facts. We had 11 different contributions from undergraduate to graduate students with study programs, like from really different study programs. We got music, we got books, we got illustrations, podcasts, and I kind of like want to highlight the three main prizes and go through them a bit. The first prize was the children's book about the life of an algae in the Southern Ocean. So it was drawn. So they did the drawings on their own and also the story, and the story kind of like highlights how the life goes on. And this book, we are currently still in contact with the two person who designed the book and submitted it to publish it. So that is still something we are currently working on. And hopefully at the end of the year or early next year, we can share when it will be published and announce it more. And that is a rather cool outcome from this creative competition. Then we had a shared second place, and the one thing on the left hand is a screenshot from a movie with really cool drawn graphics about the history of climate in Antarctica. The video is actually in English, so it can also be used. It's found on our website. I can show that at the end. And it kind of like highlights how Antarctica got from a green continent to an ice-covered continent like we know it now. And on the right-hand side, so you see the podcast advent calendar, where students just like each day in that advent calendar was a new episode describing the climate history of the Greenland ice sheet. And they did this via highlighting ice core measurements and working through that. The podcast is still on Spotify, for example, on YouTube and so on, but it's in German. And as far as I know, there is an English podcast coming now from the same group of people for this year at the end of the year. And after we finished that, we said, okay, it was really fun to do something with students, but maybe let's now move on through another age group. And currently we launched together with the AK Polarlehrer and with Rainer together, the science competition for school kids. It's called Polarprojekte, which translates to Polar Projects, where we have like across 4 age or like from 4 classes. So there's like probably the ages from like 14 to 18, something like that, where we have divided them in different age groups and gave them overarching topics about different parts of the polar regions, about the more natural science aspects to life aspects of indigenous people, to politics, through biology, like through all of that. And we are currently kind of like waiting, like we're launching it, and the deadline is at the end of the year. And it will be interesting to see what we will get submit through that. And kind of like if people are from Germany are interested in like, you can get involved in like on the national level and to get to know us, which is like, for that. So it's a national level there. You can become APECS member or become a member of the APECS National Committee and help to work conferences, plan our meetings, but you could also become involved in the international level or win other national committees. So like we have and there are different project groups on the international level for which you don't have to be an APECS council member, which are also cool. And there are a lot about outreach. There's one about podcasts and different groups. And you can also follow us on Twitter, where this is where we're mostly active and share about all the stuff we're doing. And we're currently in the process of launching a new website. This is a new website, and you find there in chapter, like a subsection about outreach, where we start to build up our own resources, what we did in the last years about outreach, the competitions, and so on. And with that, I would move over to Josephine.
Thank you so much, Marek. It's so great to see what APECS Germany is doing. So I'm Josefine Lenz. I'm currently the director of APECS, but I'm not going to talk with my APECS hat now. I'm going to present you something which is already like starting, but we will. I will join this project basically once I'm done with my doctorate. So I'm happy to share it early on. It's a new permafrost citizen science project. It's called UndercoverEisAgenten. It's kind of a national German project, but I'm really happy to receive some feedback maybe from you here. So the key message is permafrost is cool. Permafrost is a really cool topic. It's super interesting. It's something which is not clearly visible for the unknown eye, and it's changing. So it's basically going like from a cool state to a warmer state, and so it's really important to communicate this topic. So all the ground which has been below 0 degrees Celsius for at least 2 years, it's what we call permafrost. It can be any kind of ground. So here you can see me standing in front of a frozen wall. It would basically be mud if there would be no ice and no cool temperature in it. And it's in West Alaska, and when you're there, you hear it like dripping, you hear it like thawing. There's a little stream going down, and it's all like happening in a very short amount of time in summer. But it's super dynamic and changing very much. And it's very important because it's widespread. So 1/4 of the northern hemisphere landmass is underlain by permafrost. Plus, there's permafrost in the subsea. So it's super widespread. It's important, but it's not as well known as other topics like ice sheets declining, or like glaciers getting smaller, or like sea ice also decreasing. So what we did in the current project, which I'm still very affiliated with because it's very close to my heart, is creating experiments to show what's happening when the ice is thawing in the ground. So ice is not like equally distributed. There are some parts which are like more ice rich, and in very easy experiments with basically ice cubes, you can show what's happening, because the Arctic is not empty. There are people living there, and they're highly affected by thawing of permafrost. I'm going to show you a little video. I'm not sure you can hear the sound, but it doesn't matter too much. Anyways, it's only a few seconds, but it's showing you also in time lapse. Those are very easy tools to actually, bring a thawing of permafrost to the attention of a wider audience. And it's also important because permafrost can be, like, as I said, any ground, but also there's a lot of frozen plant materials on the ground. So there are plant remains which are actually like pure carbon, basically. So if it thaws, it's going back into the biogeochemical cycle, and it's going to enhance the climate change feedback. And it's easy visible when you core down the ground and you see like wood, you see like plant materials, besides even like pure ice, as I said earlier. So those topics are super important to bring into classrooms. And actually, there's a very nice feature of permafrost. You can see it from the surface if you know how it looks like. So these kind of structures you see here, like these polygonal structures, are very typical in the landscape. You can see them from space or satellite images or satellite eye, but also seeing in the drones. And what we want to do in this citizen science project is actually going into the Arctic to meet school kids in Canada. So we're going to go like West Canada, and we're gonna equip them with drones, and we want them to fly in the areas where they think it's of interest, where they think landscapes are changing dramatically. And then we want to sit together and talk about the changes they see. So we also go into indigenous communities, so they do have a lot of knowledge about their own landscapes. And we want to share this knowledge. And on the other side, we're going to go into schools in Germany. We want to work closely together with some of them who are accompanying the kind of the project for longer. And we want to co-develop with them. We want to be like co-creative with the school kids and with the teachers to create an application, an app to map permafrost from satellite images, but also especially from those drone images, which are like newly acquired from the Arctic by school kids in Canada. And by the way, this nicely drawn sketch here maybe helped us to get the proposal through, thanks to Marek. So again, close collaboration between APECS and research, permafrost research. So just today and yesterday, we had a first workshop with a handful of teachers and also people working not in schools, but in institutions or what's called not school institutions, where we discussed how we can meet together, like where we can find common grounds in the frames they are working in, because we know it's sometimes kind of like fixed, but I feel like also it changed quite a bit. So there's more flexibility nowadays in schools, and there we want to meet in like flexible work environments and to see how we can creatively develop the applications. So there will be an online tool to classify and to digitalize permafrost features. Of course, there's a lot of background material you want to produce, co-produce, co-development again with the teachers, and also evaluate how this actually works. So there will be different steps in the project. Basically, there will be like an app where you can have like micro tasks. So big task is like, map the permafrost, but of course we can divide it into small tasks and map very easily, like those polygonal structures, for example. But there will be also other tasks in between, so that's not like getting boring. And because we can hopefully apply this to a larger audience, not only like the schools we're going to work with very closely, but also use the app, for example, at exhibitions or at public presentations. And we didn't really consider this yet, but maybe you can also translate it into English and make it available to a larger audience. We hope, to create a lot of data, and this again, of course, needs like post-processing, which we also hope to do together with the schools. So it's a pilot study. It's a first German citizen science project on permafrost on this large scale, and we will hopefully get good results out of it, and especially a good collaboration, and hopefully continue beyond the project time. So we just started this summer. This is a little project team here, and we hope to expand it by teachers and educators soon. And I'm very happy to get feedback, but I'm also looking at the clock. So 1 minute left, so maybe I have some time to do a small discussion. Thank you.
It's a great project, Josephine. Absolutely. Stunning. How long is this project going to go for?
3.5 years. So it's another 3 years and 4 months. That's kind of difficult because those projects are always limited in time. And of course, it's very important to actually go back into the Arctic, especially, and to show the results. So the good thing is that we actually can build on collaboration with our colleagues who are going in this region where we are going basically every year. So we hope to continue sharing our results there, and hopefully also add with new projects.
we're going to keep you in mind for when we're developing the polar resource book, new resources. We need to put permafrost in there, don't we? We need to big up permafrost in the new polar resource book. So yeah, we'll be in touch.
For sure. In many ways.
We have a couple of minutes into the next session. So any questions? Anyone?
I have a question for like UndercoverEisAgenten. You showed that you want to depict a picture of like permafrost with drones. Like include those. You want to like allow the students, like those young children, to participate in operating the drones, or just an application?
These are the locals in West Canada, where we would like to have the teachers, of course, like accompanying the whole process, but having kids flying drones. But that's something we need to really start working on, like collaborating very soon, so we can actually find the right people to connect with. That's, of course, again, it's not super straightforward. There are several steps to take when working in Arctic and indigenous communities, but we are on it, yeah.
I think the kids will love gadgets and they love destroying stuff. So I think crumbling permafrost is perfect for them. I just had a quick question. I used to follow Terry Callaghan's work closely on Interact and other stuff. So I just wanted to know, do you work with other countries where countries like Russia, where the permafrost issues, slightly more prevalent and research has been going on for slightly longer?
So in this specific case, we work with Canada. Also for the reason because flying drones is easier there than in Russia. So there's also like things with licenses going on, etc. So that's not easy in Russia. But we do have like really extensive and long-standing collaboration in Russia from the Alphavenia Institute. So our colleagues work there since 25 or longer years, especially in the Lena Delta region. There's a German-Russian station just renewed lately. So yeah, we do work in almost all countries around the circumpolar region.
Fantastic. One last question for Rainer, if we have time. I know we are meeting into your time, but I'll just wind this up. So one question, Rainer, in terms of projects that were run on MOSAiC and taking teachers there. So in terms of content and courseware that they develop, are they free to create whatever people want, or is there a mandate by the committee that these are the resources and these are the age groups that you need to create for?
It's, if I understand you right, I would say it's open for all ages of students you want to reach, and all kinds of topics you want. So, but of course, if you want to go on a specific expedition, for example, some geosciences, it's better if you are a geologist or a geographer. And if you have biology in the background, it's good for biological expeditions. So did I understand you right, or?
Yeah, I think you answered that well.
Okay.
Thanks so much.
Yeah,
Thanks, everyone. It was a pleasure to have you here. And it's possibly the largest live panel that we've had so far. So thanks for getting them all together, Rainer. It's been a pleasure.
Yeah, thanks a lot for your work. Bye-bye.
Bye.
Bye-bye.
Thank you very much for organizing. Bye-bye.
Auf Wiedersehen.
Auf Wiedersehen.
Wow.
The only German word I know.
See you in
Bye.